I previously made a video explaining ionic bonds and valence electrons, and then the video following that spoke about the different groups of the periodic table. I took a look at that one and decided to redo that one because I thought it was a little confusing, so this is version 2. Alright, so we learned about valence electrons, and we learned that this atom would really like to get rid of this one valence electron. Why don't you take a look, count these electrons, and tell me what element this is. So if we take a look, I count 1, 2 in the first shell, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So that means that this atom represents an atom of sodium. All right, it has 1 in the outer shell. And it just so happens that every one of these elements in this column also have only 1 in the outer shell. So if you look at the group number tells you the number of valence electrons. So hydrogen, lithium, sodium, potassium, and cesium, I forget the name of the other two. All right, so 1 in the outer shell. Over here, counting these up, 1, 2, and then this set of 8 makes 10, and 11, 12, 13, 14, 15, 16, 17, and that means that that represents chlorine. Its group number isn't 7, but it is 17. There are not 17 electrons. There's only 7, so I think you can get it here, right? It's the ones column. All right, so this column of elements have 7 in the outer shell. All right, all of these: fluorine, chlorine, bromine, iodine. And then over here, if we take a look at this column, group number 16, it's going to have 6 in its outer shell, oxygen, and so on. Okay, over here, 18 has 8 in its outer shell. All right, we'll get to that. All right, so this element, or this atom, is very reactive with this atom because it has that one it wants to get rid of, and this atom would like nothing more than to fill that outer shell. All right. What's important to know then is that all of these elements are very reactive with all of these elements. All right. So if we take a look at this chlorine again, and I take the time to draw, we'll just draw hydrogen, which is really easy. Here's a hydrogen, here's its 1 outer shell, and here's its 1 electron, and perfect, fits right into the outer shell of chlorine. Same thing for lithium. If I were to draw a lithium over here, and then 1 and 2 energy levels, and so we have 1, 2, and lithium has 3 protons and 3 electrons, so that's 3, and that third one is in that outer shell, and you can see that lithium will react very nicely with the chlorine. All right, so if we just take the chlorine, it can match up with a hydrogen. It can hydrogen chloride, lithium chloride, sodium chloride, and potassium chloride, and so on. And so all of these in the ones group, very reactive with the ones within the 7 group, or the 17 group. All right, so let's put a name to all of these groups, and let's see, clear that. All right, so this group number 1, this is called the alkali metals. Group 2, these are the alkaline earth metals. Okay. Over here, 18, these guys are special because it has 8 as its group number, or 18 as its group number. It has 8 in its outer shell, and its outer shell is complete. It wants nothing to do with any more electrons. It wants to keep all 8 that it has. It's very non-reactive. It doesn't want to connect with any of these other elements. So these are the noble noble gases. Noble gases. All right. Group 17. These are the halogens. Okay, we remember that the halogens react a lot, very nicely with the alkali metals. And then number 16, put it over here. We need a little bit of room. This is the oxygen. The oxygen group. Our book calls it. I've also known it as the, let's see, CHAL, chalcogen group. I think that's how you spell it. All right. So the alkali metals, the alkaline earth metals, the oxygen group, halogens, and the noble gases. The group numbers tell you how many electrons are in its outer shell, and the atoms want to match up to have a full set of electrons in that outer shell. So the alkali metals will be very reactive with the halogens, the alkaline earth metals very reactive with the oxygen group, and then these noble gases, non-reactive, they are all set with a full set of electrons. All right, thanks for sticking around. Hope it was clear, and I'll see you on the next one.